So in this third part of this video tutorial, we're going to look at some basic ways of selecting and setting values within a data frame. So of course it's all very well having our data loaded into a data frame, but until we can actually do something with it and pull out particular values from it and manipulate that data, it's going to be a bit useless. So we're going to want to figure out how we can do that. So first of all, we're going to select columns. So one of the ways that you can think about a data frame is that it's like a dictionary, or technically it would be a mapping, meaning that there is a label that corresponds to a value. And in this case, the value is an individual series of values for one for each row. So it might not come as a great surprise, therefore, that one of the ways you can interact with the data frame is in a way that makes it look really quite like a dictionary in how you're dealing with it. And you can use the kind of same way we talk about accessing keys within a dictionary to access individual columns of data. So if, for example, I do df and then in square brackets for indexing and put the name of the column I want, what I get back is a Pandas series. So it's indexed by the row number, and it gives me the name of each of the Marvel comic characters there. Pandas is a bit more flexible in some ways than just a regular dictionary. So one of the things we can do, for example, is we can specify multiple column labels by indexing with a list of values. So in this case, therefore, we've asked it to give us passing a list of 3 columns, the name, the alignment, the power, and when we index the data frame with that list, what it actually gives back to us is another data frame which is a subset of just the columns we asked it for. So we're able to bring together the columns we want, and of course we're controlling what order they appear in by the order we specify the column names in the original list. Because indexing by the column is such a common thing to go and do, Pandas offers a little shortcut to dealing with this. And again, this is something Pandas tends to do quite often, is that where there is a way of giving us a shortcut to do something that we have to do often, it'll try and figure out a way of giving us that shortcut. And in particular, what you can do with Pandas is you can treat the column names like an attribute of the data frame. You just do dot and then the name of the column. So long, of course, as the name of the column does not clash with a Pandas function or one of the other attributes already built in. So if, for example, you had a column called info, you could not do df.info because Pandas wouldn't know, did you mean the column called info, or did you mean to go and call the method info that tells you about the data frame? But as long as you don't have a clash like that, then you can use this attribute form just as easily as well. Selecting rows is a little bit different. So we have a slightly different syntax. We use a special attribute of the data frame, LOC or lock, which is short for location, in a way to index into the rows. So for example, if I do df lock and then square brackets, because I'm indexing the lock attribute with 0, which is the label for the first row, then it pulls out the values for the first row. And important here to notice is that 0 that we're using with lock is simply because the row is labelled by numbers. In the index is a set of numbers. If the index is something else, then we'll have to use whatever the new labels are in the dot lock. Again, we'll come to that shortly. Dot lock behaves a bit more like a numpy array, in that you can index both rows and columns with it. So for example, if I ask for df.lock and then pass it 0, quote name, you can read that as get me the first row and then the column, or get me the row that's labelled 0 and then the column that's labelled name within that row. And that gives me the value Batman, because that's the name of the first superhero we had. So because the columns are currently labelled as strings, in this example, we're referring to the label of the column, like the name, the string. But with the rows, of course, they're labelled by numbers, and so we're using the number. As with the dot columns, we can also use a list of values to get a subset of the data frame that we're interested in. So in this example here, we're using df.lock, so we're indexing, asking for a number of rows and also a number of columns. We've passed it two lists. We passed it a list of rows we want and a list of columns we want. And so that's pulled out a little subset of the data frame that we're interested in. One of the really powerful things, and actually this is a technique which works with NumPy arrays as well, is to be able to go and select rows we want by using a sort of criterion or a condition. So this is actually really easily done, but it looks a little bit complicated to start with. So the first thing we're going to do is we're going to take one of the columns and turn it into a series of true or false values. So for example here, I'm going to take the alignment and I'm going to ask it for alignment equals good. So that's testing, is the value of alignment good? And it's going to do that for every row. And so that produces a series of values which are 6 trues and 6 falses, because in my original data frame the first 6 rows are superheroes and the last 6 rows are villains. Okay, so I can do that. Pandas actually gives us some more powerful ways of doing tests. So for example, there's a dot between method which you can apply to a series, and so in this case it's going to give me true or false for whether the power column is between 30 and 70. And now you can see there's a bit more of a mixture of trues and falses in there. And you can do is in, meaning is it one of those values, and again that does trues or falses. And we'll see a few more of these tests later on in the video tutorial. So once we've got that series of true and false values, we can pass it into lock and ask it to use that to select the corresponding rows. So if we pass lock that series of true and false values, every time that series is true, it's going to select that row, and every time it's false, it's going to ignore that row. So if I ask it for the power between 40 and 70, then in fact there are only 2 rows where that power value is between 40 and 70, and it's pulled them out for us like this. So the df.lock, I'm indexing the data frame by row, and I'm passing it in a series of true and false values, one true and one false value that corresponds to each row. So then just pull out the rows where the corresponding value was true. Indexing with a series of true and false values is a very, very powerful technique. As I said, there's an equivalent actually in NumPy arrays where you can index an array with another array of true and false values. And it's a much more efficient way, both in a Pandas data frame and in a NumPy array, of selecting rows without going through a tight loop and considering each row in turn. It allows the Pandas or the NumPy library that's underneath it to do that loop around all the rows in much, much faster code than you can manage in Python natively. So it's a better way of dealing with it, particularly when you're starting getting really, really large numbers of rows to deal with. There's another shortcut actually here. If you just index the data frame with a sequence of Boolean values, true and false values, then Pandas is going to assume that what you're actually wanting to do is select particular rows of the data frame, despite the fact that usually indexing directly on the data frame is trying to select columns. So in fact I could just do exactly what I did before by doing df and then directly indexing it with df.power between those 2 values. And I think you can see that, okay, it saved us 4 characters, but it makes it a little bit more readable and kind of I think is sort of intuitive as to what you're asking for there. There are even more flexible ways of querying data using the .query method that we're going to come back to in a later part. If we want to add new columns to the data frame, then that's really easy, because in the same way that you can add a new value to a dictionary simply by setting a value, a key value using indexing, you could do the same thing with a data frame as well. So here I can just do, so I create a totals by pulling out the data frame, the columns I'm interested in, and then I'm just using sum. Again, we'll come back to some of the ways we can analyze this, but that's simply going to add up the column values from those columns, and I go and create this data series called totals, and then to add it into my data frame as a new column, I simply do df and then square brackets to index the columns, call it totals, and set it equal to the values I've just calculated. So that's just in the same way you do that as with a dictionary. It works with a data frame, except rather than just storing a single value of some arbitrary data type, what you have to do is store a set of values where you've got ones for each row. And so we can see what we've just done here is we've just added a total score to our data frame there. We can use something very similar to write values into the data frame as well. So for example, I can do df, select the total, and then so overwriting the values, I'm just essentially in this case dividing through the total score I had by 6. So now effectively I'm calculating the average value. So I'm just overwriting the value I had previously. To add a new row or to update the values in the row, then you can just pass new values using the .lock attribute. So again, that kind of works in a similar way. So in this case, I've got df.lock, I've specified the row I'm interested in, and now I'm passing it a series of new values. And now you can see that I've overwritten the values for Captain America with a different set of values. The other thing to notice what I've done here is I specified a none value for the total column, and when I've put that in to Pandas, it's come up and said that's an NaN for not a number. Well, I mean, none is not a number, but Pandas is quite flexible about how you can tell it that this is a bit of missing data, and it will give the missing data a value of not a number. If you want to set individual cell values, then again, you just go and do that with the .lock. You just have to specify which row and which column you want to set that to. So in this case here, I've overwritten that missing data value in the total column. So I've specified I want df.lock, square brackets because I'm indexing, row 2, or the row that's labelled 2, the total column, and then the value that I want to write into it. And you can see I've then updated that value. So setting values is just the same syntax as you'd use if you were using a dictionary. If you want to set whole columns at a time, you can just do that directly on the data frame. If you want to set for rows, you need to use the .lock attribute to get you to index into the rows instead. You can also, as well as using the .lock, the flexibility is kind of a bit of an overhead. So Pandas also offers a .at attribute, which works pretty much the same, but it's used for just setting single values at a time. So with .lock, we could set values across a whole range of things, multiple columns, multiple rows. But if you really just want to set one value, you want to do it quickly, then .at is just a little bit faster. And it both allows you to get at the values, but also to set the values as well. So in this case, I've asked it, so what's the value for the combat column in row 2? It just comes back straight away with a number, and I can use that to set the number as well.